Hello everyone, welcome to my channel. I am Dr. V. Jayakumar. I am making lecture videos for the benefit of mechanical engineering students. In this video, we will be solving numerical problems on degrees of freedom of planar mechanisms involving redundant degrees of freedom. So let's get started. First, let us understand what is the meaning of redundant degrees of freedom. A mechanism has many links. If a link in the mechanism can be moved without producing any movement in the remaining links of the mechanism, then that link is said to have redundant or idle degree of freedom. That means a link can have a motion, but it will not in any way affect or influence the motion of the other links. That means the motion of that particular link is redundant, is ideal, because it has no effect on the motion of the other links. In that case, the formula that we have used to find degrees of freedom, which is nothing but a Kurzberg criterion, will not be valid as such. We need to subtract that number of redundant degrees of freedom from that formula, which we call it as a effective degrees of freedom. So these are some special cases of mechanisms. So what we need to do before solving the problem, we need to carefully observe, identify whether we have any redundant degrees of freedom link. We will illustrate this concept with few examples. So this is the problem. Determine degrees of freedom of a cam follower mechanism. So as always, first let me find number of links. So this is the fixed link 1. Here we have fixed link 1. Cam is the link 2. Here we have the lever, which is link number 3. Here I have a roller which can roll. So this is link number 4. Number of links is equal to 4. Now let us find number of binary joints. This is one binary joint, one binary. Then between link 3 and 4, we have one binary, right? So we have 3 binary joints. So L is equal to J is equal to 3. And very interestingly, we have here point or line contact, and hence it is a higher pair joint. So therefore H is equal to 1 as well. So directly we will be tempted to use Kurzberg criterion, but hold on. Let us closely look into the motion of the roller 4. Here the roller possibly can rotate without having any influence on the other link, say link 3. So roller can have a motion without causing movement to other link, and hence roller can be the redundant link. Therefore, we have one redundant degrees of freedom in this mechanism which needs to be subtracted. So what is the effective degrees of freedom? So substituting these values, we will get yes, that's the answer. Degrees of freedom 1 means one input motion is enough to produce constrained motion from this cam follower mechanism. That means if I couple a motor to a cam, that should be sufficient for us to get constrained motion of this cam follower mechanism. Shall we solve problem number 2? As always, let us identify fixed links. Link 2, link 3. Then we have link 4 there. So therefore, number of links n is equal to 4. Shall we identify number of binary joins? One binary there, one binary there. What about here? Here we have sliding joint. Here as well we have one sliding joint, which is nothing but a lower pair. So equivalent to one binary. Therefore, we could write number of binary joints as 1, 2, 3, 4. Is there any higher pair? No. Before applying the Kurzberg's criterion, we need to identify, do we have any redundant degrees of freedom link here? Just by observing, we can understand that this rod 4 can slide without causing any motion to other link. So here rod can slide without causing motion to any other links. It means that link 4 is a redundant degrees of freedom. So now we can apply this modified formula. So this mechanism results into structure as degrees of freedom is equal to 0. Okay. Hope you have understood the concept of redundant degrees of freedom and how the Kurzberg equation should be modified accordingly. That's it. Thanks for watching. Take care. Bye.